Okay, we're going to use a chi-squared test to verify that there's a significant difference or not between these API scores from the high schools. So I might be talking kind of fast to make this a short video. So let's get started. The first thing you got to do is break out the chi-squared formula. The chi-square is the Greek letter. It looks just like our capital X squared. That's the test statistic. The sigma means add them all up for each individual. The O stands for observed values. Those are values that are already recorded in a table somewhere. And the E stands for the expected values. And that's where all the work is. But let's go ahead and get started. The easy part are the observed cell counts. That's the data we already know from the problem. This is where the work comes in, is finding the expected cell counts. So if the null hypothesis were true, which states that there is no difference between the high schools, they're all basically the same, they're all relatively equal enough, there's no significant difference. So since we only have one row here and 5 different schools, we're simply going to divide the total number, 3629, by the total, 5, and that will give us an average of 725.8. So that would be our expected count if the null hypothesis were true. So let's go ahead and look at the formula again. Bam. So we need to find a difference between the observed and the expected outcomes first. Let's go ahead and do that. So there's our observed on top, our expected on the bottom. We'll just simply subtract each one. So that's that. Next step. Going back to the formula to see what we do next. Looks like we square each difference. Let's go ahead and do that. So here's all the differences. We're simply going to square them. That was easy. Back to the formula to see what we do next. Now we take that squared amount and we're going to divide it by the expected value. There's that amount. Let's go back to the formula, see what we do next. Looks like the sigma signal, and that means add them all up. So let's go ahead and add them all up. This column, this is the ones we're going to add all up. And we get a grand total of 2.9 blah blah blah, and that is our chi-squared statistic. So that's the first part. Second part, find the degrees of freedom. Degrees of freedom, we use the formula. Number of rows minus 1 times the number of columns minus 1. But since we only have a single row, we're just going to go ahead and use the number of variables, which is 5 minus 1. So that's going to give us 4 degrees of freedom. So now we know our chi-squared statistic and our degrees of freedom. Guess what? We're going to look this up in a table. But it's a different table. It's the chi-square distribution table. I cut out a little chunk of the table just to work in this problem. So we're looking at 4 degrees of freedom. That's this row. And we're looking at a chi-square of 2.94. And it looks like it's not even on this chart, but it looks like it's going to be way over here somewhere. Right? You're following? This is 5.39, 5.99. It just gets bigger going to the right. So our 2.94 is to the left, which means that we have a p-value that's larger than 0.25. That's all that means. Let's double check this in MS Excel. Please hold. In Excel, pick a cell, any cell. Go to the formula bar up here. Click in X. You're going to put on statistical, go down to chi-dist. Pretty easy. And our chi-squared was, and our degrees of freedom, and this is the p-value for our test statistic, 0.5, much greater than 0.25. So of course, you're not going to reject the null. There is no significant difference between the API scores.